Welcome everyone to the Tulsa.net user group tonight. Jared Parsons with Microsoft is going to talk about the C# language. Jared, thank you so much for presenting tonight. We really appreciate this, and I'll let you take it from here.
Awesome. Well, thanks for having me. And thanks everyone for coming tonight to hear this talk. It's Let's Design a Language feature. Kind of why even the seemingly simplest changes to the C# language can take many years or decades to ship. A little bit about myself. My name's Jared Parsons. I'm the C# compiler lead, and I'm a member of the C# language design team. I've been at Microsoft for about a little over 20 years now. I've been working in the .NET languages space for about 18 years. I started on the Visual Basic compiler, moved over to the Visual Basic debugger and IDE for a little while. And then I spent about 5 or 6 years in research on C# and the Midori project and kind of the system C# language. But I've been back on the mainline .NET team for about the last 7 years in the C# compiler lead role. And so definitely really excited to kind of talk about the language design process here and kind of expand it for other people. So about this talk's kind of a couple parts. First part is, how do we design a language feature? What's kind of the process? What are the things we talk about? And kind of how it's a very iterative process over time. And then we're going to take that kind of lesson and then walk through the design process of a feature that we're shipping in .NET 9, params IEnumerable. And this is kind of extending the existing params array support into other types. And I'm going to walk you all through like how that design process worked and all the kind of twists and turns that it took around through the years. So do please feel free to ask questions. This is a user group. It's not a conference. Questions are welcome. Drop them in the chat. I have my phone sitting next to me during the meeting, so I should be able to see them pop up. And I'll stop at various points to kind of run through them. And if I'm responding to you, feel free to unmute, chat with me. There is kind of trying to keep the time of the talk around 60 minutes. So at some point I might kind of cut questions off just to kind of get under the wire, but I'll be here afterwards to kind of finish up with any questions you all have. And bonus points are awarded for lame dad jokes that you can fit in throughout the presentation. So first off, let's talk about the language design process, or as I like to call it, bike shedding at a whole new level. So the C# language design team. So this is the team that is responsible for designing C# features. There is one full-time member. It's Mads Torgerson. Worked with him for years, and I still butcher his last name sometimes. The remaining people on the language design team have different jobs. So like me, I'm the C# compiler lead, but I also participate in language design. We have people from all over the company. We have people from the ASP.NET Core team, the C# IDE team, the .NET Libraries team, and we often have people from around the company come and do presentations. And the reason we do that is to make sure that we have a very broad set of views and kind of opinions when we are talking about changing the C# language, to make sure that we are kind of doing our job to make it fit for all the maximum amount of .NET scenarios we can, and not just kind of thinking very narrowly in kind of some of our own little areas of expertise. So the structure of the meetings is we meet 2 hours every Monday and Wednesday. The meetings are open. Anyone at Microsoft can join and listen in on them. But generally, the actual talking and presentations are mostly limited to the language team members. And we post all of our notes from these meetings to GitHub within a day or two of the meetings finishing. So mostly in the meetings, we discuss proposals. So proposals are really kind of a formalization of a change we want to make to the language. These talk about what problems we're trying to solve. What new syntax are we potentially introducing as a part of this change? Any kind of the low-level stuff we're doing, like we're going to be changing overload resolution. Are we changing how name lookup works? Do we need to change how things look in metadata? Do we need to put new attributes in our code so that debuggers can read something, or we're hooking up languages features across languages and we need to give some information in metadata? All of these documents and these proposals are done in the open. You can actually go to github.com/.NET C#lang, and you can look through all the proposals that we've had for basically the last 7 years. And in particular, I'm going to take a second here, and we're actually going to look at the proposal for params IEnumerable that we're going to be talking about today. Now, the first thing is you might look at that and say, that doesn't look like IEnumerable, that looks like a completely different type. We're going to get to that and talk about why the proposal ended up in this space instead of IEnumerable. But when you look through these docs, you can see they pretty much all have this basic format. They talk about a quick summary. What are we trying to do? What is the big motivation for what we're trying to do here? This is talking about how params arrays works today, some of the limitations, and some of the things we could fix by letting it work for other types like read-only span. And then we get into some of the detailed design. We start talking about some of the more examples. We get into the really readable part of the spec where we talk about all of these formalizations of like how we change all the speckies. This is the easiest part of the design to read, by the way. Joking. This is awful. Takes years for me to even be able to read that Greek. And then it also starts talking about things like, okay, we have this feature, people are going to write this code, but what is the code the compiler is actually going to emit to disk when people use this feature? And so and we tend to go into very great length about this. What type of things do we need from the .NET runtime to make this feature work? And and you can see even examples of how this is how we think libraries and the .NET runtime team are going to adopt this. And we want to keep these in focus when we're making changes or thinking about these things. And then most of the time, our specs end with question, like an open issues question section. These are things that when we're writing these formalizations, like we don't always have the answers. We often hit kind of edges and we're like, we don't know what the answer to this question is, or I think the answer should be this, but I want to make sure that people in the language design understand that I had to think a bit about this before I kind of proceeded. And you can see here, there's this little question at the bottom that's kind of important here, like, should we support IEnumerable? All right, real quick, I see a question, is this the spread? Is this like a spread operator? We'll get to that in just a minute when we talk about like how params works. So where do we get these proposals? Where do they come from? So ideas come from a number of different areas. Sometimes they just come from the C# language design team members. If you're a member of the C# language design team, it's generally because you're passionate about languages and you kind of work with C# right now. Most of the people who work are on this team work in other languages. For instance, I ran the Go compiler team at Microsoft for a number of years and did a lot of work in that. I also was a big F# hobbyist for a long time. There are other people on language design who are very passionate about like other languages. We have people who understand Rust, people who have big familiarities with low-level C and C++. And oftentimes they come to us saying, hey, there's this great, awesome feature in this language called F#. They have this really powerful pattern matching capability that we just have no equivalent of in C#. And I have an idea on how we can take that feature and kind of adapt it to work in C#. Really, though, for my take, though, I think the best ideas often come from talking to customers, like at conferences, on GitHub, or in user feedback. Basically, like, what are the problems you're facing? What are the things you tried? And more particularly, like, what are languages doing better? Because oftentimes, like, I talk with customers, and they're like, hey, we're hitting this particular problem. We tried solving it using .NET and C# in these ways, and we kind of failed. But I also, do Go as a hobby project. And I know that Go solves this problem really well because they have a very specific way that they do package building, or they have a different way of combining GitHub repos. And I think if C# had something like this, we could, really solve these problems in a new way. And like I said, I think customers are key because if you look back on the history of a lot of the features we shipped over the last 5 or 6 years, many times it comes from us just talking to customers about their problems. For instance, source generators, which is something that has been very much heavily used in the last few releases of C# for things like the regex generator, the logging generator, JSON generators. Those were all a response to the .NET Razor team coming to us and saying, we're having real problems building the product. We can't integrate the C# compiler into our pipeline the way we want to. And source generators is kind of the result of those conversations. And it turned out to be something we could very much generalize to the .NET ecosystem. File scope namespaces and minimal APIs. This is a response to us looking at kind of Azure funnel problems or looking at competing with other ecosystems. If you did like Hello World for Razor and then compared it to like Hello World for Go or Hello World for Node, we were lacking. Like the other ecosystems had a much better solution. And we've looked at it and we thought about it. And we found a number of features we could do in C Sharp, like file scope namespaces, to really close the gap and make .NET like a more competitive tool in those spaces. And there, like I said, there's a couple other ones here. Function pointers, that was something that was responsive to like Bing perf investigations, turned out to be a very big win for low-level perf writers and the .NET ecosystem. And pattern matching, as I mentioned, from F Sharp. So the way we evaluate these proposals is we often look at them from a number of different angles. Like the first one is like the problem being solved. We tend to ask questions like, could we solve that problem a different way? Like when we were looking at source generators, one of the things we said is, okay, do we need to invest in the compiler here? Or could we just make MS Build more toolable and tell people to go write better MS Build code instead of C# code? Sometimes we look at a problem and ask ourselves, like, is that even worth solving? Language features are a very big hammer. And sometimes we look at the problem and we're like, that's a very real problem, but it's, a pretty tiny one. We should maybe be spending our resources elsewhere. Compatibility is an absolutely enormous one. C# is 20 years old now, even older than that, I think. And we have 20 years of features, 20 years of library code using those features, and 20 years of customers interacting with that. And we often have to think like, how does this new feature interact with all those existing scenarios? And can we do it in a way that feels very expressive and natural to C# without causing undue friction? Performance is another one. With these features, are we pushing customers to the pit of performance success, or are we pushing them to the pit of failure? There are other things like aesthetics, like does this feature really look and feel like you want C# to be? So if we show this to customers, it might be new, but do they still think it looks like C#? And one which I think is like very underrated is the tooling experience. So by that, what I mean, like when we design features, we think about like how will the IDE team give us intelligence for this feature? How will edit and continue work? How will debugging work? And that is super important part of language design is how can we tool around that? Because customers consume a language through an ecosystem of tools. And that includes like Visual Studio, your debugger, your compiler, your CLI, your templates. If you only design a feature to work in a compiler, you don't have a product, you have a toy because no one's going to use it. To really get good customer adoption and really get the depth you want, you have to really design the entire experience around a feature. Sometimes that's really easy. Sometimes, in the case when we did things like records, primary constructors, it can be very challenging to get that tooling experience in the right place. The other thing to keep in mind is what we evaluate changes over time. C# is 20 years old. This started off as a line of business application language for Windows. Now it's open source, cross-platform, and runs web services. So what matters release to release changes quite a bit. This can open doors to features we thought weren't viable. It can also close doors to features we thought were kind of slam dunks. And the last little bit is language features are very expensive to implement. The design is a labor-intensive process. In terms of actually implementing them, you're often talking about coding across a number of teams. You have to implement the compiler, you have to add VS support, you have to integrate it into the .NET runtime APIs, and oftentimes you actually have to change the CLI to change the templates to take advantage of those features. And after that, we have to spend time educating customers, producing documentation, showing them samples. And as an entire group, we have to commit to supporting these features for basically ever. So these are very big hammers, and we don't take the implementation of them very lightly. We treat them very carefully. And this all factors into like when we decide to go and implement a proposal, because sometimes language design will say, hey, this is a great idea, but we're not going to do it this release for any number of reasons. And the decision on when we should and shouldn't implement is usually driven by a couple of different things: the overall theme of the language for that release, any overarching scenarios that we're kind of looking at for .NET or DevDev right now. For instance, things like one thing we're really focused on today is AI. And so language features, which are kind of like very helpful for our teams building AI-driven scenarios, like those tend to get prioritized right now where they may not have been prioritized 2 years ago. And oftentimes we often prioritize scenarios which tend to unblock critical things for partner teams. All right, so now we are going to shift gears and we are going to talk about params IEnumerable. So here we're going to drop into Visual Studio and talk about this feature. So the first thing I'm going to do is we're going to do a little bit of a recap, and we're going to talk about params arrays here and what problem they solve in .NET. So you can see here that I have a little simple .NET application. I have a function which is building content based off a number of lines that I'm passing in. And I'm creating this little string builder type here in order to kind of build up the string efficiently and return it from the caller. And I'm relying on this function here, append lines, to kind of put these lines into the builder. And if we jump and look at that, we will see that this is just a very simple method which takes an array of strings. Now, the problem with this method is it's really good when I have collections of strings. But what happens when I want to actually, say, type some strings out? Like I want to, say, pass in like demo code, because I'm a very creative person as a compiler. So this doesn't work because there's the only overloads we have for append lines here are ones that take essentially a single string or an array of string. What params, the only way to kind of call this code is to use this really like ugly like code where I go out and create an array here and pass it manually. And that really sucks. This is not good. Like this is not easy to read C# code. In C#1, we've solved this by introducing the params modifier. So what params does says that, hey, when you call this method, you can call it in one of two ways. The first one is you can just pass an array of lines directly into there as a single argument, or you can just type the arguments out by hand. You can just simply put these elements in line. And then what the compiler is going to do under the hood is it's just going to create that array for you. So it's going to create a new string array here. It's going to pass in demo code. And then it's going to implement this by calling builder.appendLines. And so this is essentially a convenience feature for developers and a very popular one. So this is a feature that gets used in a number of different places. If you've ever used console.writeLine, if you ever used like string.format, logging APIs, a lot of things around add range, these tend to be implemented by using params. It is the variable number of argument convention for .NET. Now, given that, this is a feature that was introduced in C#1. It's been with the language the entire time. It is very integrated into the kind of the BCL there. So now, though, the problem is this was all done in .NET 1. And if you think back to .NET 1, it was a very simple language. We did not have generics. We did not have strongly typed collections. Really, the only strongly typed collection that we had were arrays. That was the only way you could have like this type of very nice input. Well, then along comes, in about 2007, the C# language introduces LINQ. And so LINQ is now in the system, and people are starting to write code like this. They're saying like, hey, I have a new list of persons, and I have an IEnumerable, yes, LINQ, E equals, from P and persons, where p.age is greater than 21, select let's do last name. But what happens around this time is there's a big shift in what customers are using. Customers, up until this point, were very, if you wanted strongly typed collections, you were passing arrays around everywhere. But now with the introduction to LINQ, we are pushing customers into this avenue where they're using IEnumerable everywhere. And so they started coming to things like build content. They're like, hey, I want to call this build. It really helps if I can type and talk at the same time, and I'm not great at it. So they want to say call this build content method and use IEnumerable now, because that is their common exchange type. But if we kind of follow this pattern out and say that we're going to switch everything to IEnumerable here and kind of walk through the code, what ends up happening is we start bottoming out on this append lines method. And just to make this demo a little easier, I'm going to go ahead and move this method as a local function here. so we can talk about it, all the code in like one nice little place. So the problem that people started hitting is now they're like, hey, I want to start using IEnumerable here. But in C# in 2017, this time, this was illegal. This was an error because we didn't support params IEnumerable. And this is the first time we started getting, let's do a language feature. Because our customers came to us and said, hey, you've done all this work to convince me to use IEnumerable, but you're not fully supporting the language because you didn't make params work for this. And so now I'm kind of at a standstill. I can't write this code and it's blocking me from adopting params. I'm sorry, it's blocking me from adopting link. Could you make link work better by putting params in front of IEnumerable? Now, if we look at this, and this is where kind of the language design process started. We look at this from the compiler perspective and said, okay, what would that mean if we did this? Sure, we can say putting params in front of this, we will let people have the two methods of calling. One where they pass the element, the entire collection themselves, and one where we just let them write the nice and easy consumption code, and we just create the collection under the hood for them. Now, at the time, we had to make a decision, like what would, like when you're saying, hey, it's pretty obvious if you're passing to a params array, like what type you need to create. Well, you create an array. For IEnumerable, we had to make kind of another decision, like what type do we create here to pass the values? Because IEnumerable is an interface. It's not a concrete type. Well, we said there's nothing wrong with arrays here. Arrays are really efficient. They implement IEnumerable of T. We could just do the exact same thing here. When we have this calling convention where the elements are inline, under the hood, we could just create an array and pass it just as we did before. And so this is the essence of the feature that we were designing at the time. So params IEnumerable. This is just like the existing params feature we have in the language. It has all the same rules for the call sites. It has the compiler generates the exact same code. We're even using the same keyword. So like, same everything. Like, how hard can this actually be to implement? So it turns out it's actually pretty difficult. So the problem that we faced is varying. So to give you kind of a precursor to like how difficult did this of a design of this turn into, does anyone have any guess on when the first time we tried to add this to the language was? No guesses. Let's see. I don't. So the first time we tried to add this to the language was 2007. So going on 17 years now of trying to get this feature into the language. And the reason why is what I alluded to before. The reason why we started trying to do this back in 2007 is 2007 is about the time that we are doing link in the language. So 2007, we've put language integrated queries in. Customers are pushing us to use IEnumerable everywhere, and we don't support this, and so we can't move forward. But in 2007, the design was just exactly as easy as I laid out here. It's a very straightforward thing to implement. But we ended up rejecting it for a very good reason. Link was really hard to implement. It turns out like when you have a new query syntax in your language, you introduce anonymous types, you're introducing condensed lambda expressions, increased type inference and language, query modifiers. That is a lot of work. And the C# team was so overloaded with getting link to ship that even tiny little features, oh yes, and expression trees, I forgot about those. Those are amazing. That's the gift that keeps on giving. I can talk about those for a long time in terms of compatibility. But like when you're doing that much work, even simple things like params IEnumerable can end up like just, it's the straw that broke the camel's back. And we just said, you know what? That is not necessary for us to deliver this feature. We're going to move on. And so 2007, link comes and goes, and we don't actually ship params IEnumerable. The next time this came up is in 2010. So in 2010 is the genesis of immutable collections at Microsoft. So for anyone here who's ever used like a mutable array, immutable list, immutable dictionary, Those started coming into being around 2010. That was when we started passing them around at Microsoft. We were doing a lot more tools and managed code and a lot more complex things. And we knew immutable data structures were important. And we got the exact same feedback. We had people calling us and they're like, hey, I have a method that's taking these immutable arrays and I want to be able to have this like really easy calling convention. You guys won't give me params. And so when I call M1, I have to do this like really awful, like create of, what do I use here? Ints. I have to do this really awful syntax for how I create these values where I pass in like a new, I can't remember if it's like a new at the time because we didn't even have those weird param ones, like new int, 1, 2. Those ones back then had a little bit different ones. So, but we had this like really, really awkward calling convention and people were coming to us saying, hey, immutable collections are amazing. And you guys are making them so hard to use. Like, can't you please just give us params so that we can call this easily? And in 2010, we looked at it and we basically said, not right now. And the reason why was because at that time, immutable collections were kind of an idea. It wasn't a product. Like today, if you're using an immutable collection, you're consuming them through a very specific library, systems collections immutable. That didn't exist in 2010. Instead, there were a bunch of code files and like handwritten DLLs we were passing around between projects. And we said, we can't really fix this scenario because it's not actually a product. There's nothing here for us to fix. It's an idea. And so in 2010 was a case where we just said, not right now. And we moved on. Now, some of you might be saying like, oh, you went from 2007 to 2010, like you waited 3 years to look at this problem again. Well, back in I think it's called the late aughts, that was back before .NET Core. Our ship cycles were 3 to 5 years. So for us to put something down in 2010 and look at it again 3 years later was actually fairly normal because it had really long ship cycles that had a lot of bake time. And we often spent, and that was also when not shipping a feature in one release was really bad because it's like, man, if I don't ship this in this release, it's going to be 3 years before I see this again. So, but 2010, once again, we kind of passed on this idea. The next time it comes up is in 2014. So in 2014, there's a lot of things happening, but the biggest one is we are in the middle of shipping Roslyn. So for those of you who are unfamiliar, Roslyn is a complete rewrite of the C# compiler. From its original inception, the C# compiler was basically a C++ project. Most of our tools were written that way, but we kind of hit a limit for what we could achieve in that code base in terms of tooling. And around 2010, we made the decision to rewrite the compiler in C#. 2014 is about the time we started trying to ship this new compiler to customers. And this provided a lot of advantages to us, but really, for the most part, it was telling customers like, hey, you're getting a brand new compiler and no new features because we spent all of our time rewriting this thing from scratch. And so kind of the last second, we said, we really should put some features in this compiler to make people feel compelled to move to it. And one of the things we looked at is, hey, that params enumerable thing, we've talked about that before. That's easy to implement. Let's go ship that now. Like we can get that done, we can add value, and we can move people forward to Roslyn. Well, part of the problem is with that release is we put the cart before the horse. We basically, I don't know if you've ever been involved in a rewrite of a project, but I'm going to tell you right now, when you have a product, we're moving it from C++ to C#, and you have 10 years of compatibility concerns and millions of customers, shipping that, just getting your compatibility right, is an entire feature in itself. And the C# team kind of messed up. We started investing in features when we really should have been investing in shipping the product, which is getting our compatibility right. And so while we had an implementation of params enumerable, we had it all spec'd out, we had to throw it away because we ended up saying, no, we have to put all of our energy on compat right now. So we threw it away. And so that takes us to 2017. So 2017, we once again revisit this idea. Like, come on, let's just do params enumerable. We almost shipped it before. Let's ship it now. But a really important change had happened between 2014 and 2017. And that is we had started to ship .NET Core. And .NET Core was a major change for the .NET ecosystem because we went from this line of business application framework to cross-platform, open source, and an emphasis on doing things like web services. A big part of that change was a huge emphasis on performance and making sure that everything we were doing really fit into that performance mindset, so that we could make sure all our services were scaling, we were adding value for customers every single release. The problem is that made us reevaluate our params implementation with a new eye. Because look what I'm doing here. Every time I call this append lines method, I'm allocating an array, I'm throwing some values into it, and then I'm throwing that away. I'm throwing that array away. And if when you look at these the worst is for APIs like String Builder, where you tend to have these params, they tend to be methods you call a lot in sequence. So it's very common to see things like basically calling append format on a builder where you're like, hey, location, and we're going to pass in that location argument. You might say, hey, we're doing dates here, pass in dates. And the problem is every single one of these calls, if you look at every single one of these calls, actually I had them up there. I forgot I added them before, but every one of these calls in this method is allocating an array, except for the lines one, is allocating an array and throwing it in the trash. And so from a performance perspective, it's very inefficient. And worse off, this is String Builder. This is a type that we told customers like, hey, building strings is very expensive. If you want to do it efficiently, please use a String Builder because that's the way we want you to build strings up efficiently. Well, we've told them to go use this type, and then we're having them use these methods that is kind of not that performant. And so we've kind of pushed customers in one direction and kind of hit them over the head with this other one. And this problem was actually so severe in some cases that if you go and look at how string.format is implemented today, you'll notice when you look at string.format, there's not just one overload, there's many. There's a version that has 2 objects. There's a version that has 3 object parameters. There's one that has 1. And down here somewhere is the one that has the array. The reason that is done is because the C# compiler will only call params as kind of a last resort. If you have an overload that takes like 1 object and you only pass 1 parameter, we will call that one instead of going through kind of the allocation of the array. And the .NET team looked at all these append calls. We found out the most common pattern was using 1, 2, or 3 arguments. And so we optimized all of those APIs to have those extra overloads so we could avoid the allocations. And even worse, to make this kind of feature even worse, is it's not even that params IEnumerable was as expensive as params array. It's actually more expensive. So if you do a for each on an array and you go and look at the actual compiled code, it's just a for loop. The compiler just translates that to a for loop, no problem. But if you look at how it works on an IEnumerable, under the hood, we end up basically writing this loop, which is get enumerator. And then this just becomes while e.move next, use e.current. The problem here is this call to get enumerator is actually allocating another object. So it means there is even more allocations here that we have to deal with. And worst is, because of the nature of arrays and the nature of IEnumerable, there is no way for the compiler to reuse arrays. We're just calling a method that takes an array. We can't say oh, that method call is done. Let's just reuse the array again, because we don't understand anything about its lifetime. And so that means there really wasn't any out for us. And so in 2017, when we were looking at this feature again, in the context of the current environment, we had to say to ourselves, are we making the .NET platform better or worse if we do this feature? And we eventually decided that we weren't confident we were making things better enough to move forward. We were really concerned about the performance impact of this. And so in 2017, we once again punted on the feature. But And I will say at that time, it almost kind of looked in some ways like maybe we're never going to do this. Like maybe the perf is just never going to be where we want it to be and we're never going to make it. But at the same time, there's another feature that we were introducing to C# that was pretty nice. And that was span of T. So spans, if you're unfamiliar with them, is a type that can unify all of the different types of memory storage in .NET. So you can represent pointers, arrays, and strings as spans. And what's really cool about them is they can be allocated on the stack. So you can use this really intuitive stack alloc keyword. You can allocate a collection of objects, which is we have a linked to basically array here that's allocated on stack. Now, we were looking at this feature. We were implementing this feature while we were rejecting params IEnumerable. And we all knew, we were like, okay, one day we're going to be able to write this code. We're going to be able to write params span of string items here. And this is going to work for us. One day we're going to be able to write that code. Hold on a second. But at the time, we couldn't, because even at the time when we're doing all of this work, there were some limitations in how spans work. So you could not stack alloc basically strings. You could also not stack allocate objects. Really, you can only stack allocates int, floats, doubles, longs, and a few other and byte types. So in 2017, we were basically kind of in an impasse. On one hand, we're like, okay, params IEnumerable, we don't really know what we're going to do with that. But we also said, we are going to be able to make params better in the future. When we have a little more capabilities around span, we're going to be able to put params in front of them. That will mean all of our call sites don't allocate on the heap. They all allocate on the stack. And so this will be a perfect marriage of features. We can reuse these. We know what their lifetimes are. They don't allocate on the heap. This will make us have an amazing variable argument call syntax. But we can't do it quite yet. Okay, so there was a question from Matt. Doesn't variadicity, I'm not a great English speaker, even though I live here, make default parameters harder? Are you talking about the fact that you can have different types that get put into a pin format? So that basically when you call things like a pin format, you can basically, one argument can be int, one argument can be string, and one argument can be double?
I was just referring to the flexibility of the signature itself, like how many parameters it has even.
Oh, how many parameters can you take at the call site? Oh, you can put as many as you want. You can just keep, writing and writing and writing, because our only limitation is under the hood. We're just at, for arrays, we're allocating an array. So it's how big can an array be? So you can just keep adding them as much as you want.
I'm asking this without even knowing, but what would you do? What would happen if you had a params parameter, but then also had an optional parameter? I guess you probably can't have that, right?
You can do them in specific orders. Optional parameters always have to appear last. And so there are some rules for mixing optional parameters and params. They get kind of intricate. Usually it can get kind of funky in the times. I don't recommend doing a lot of that. But you can make it work. We have a number of APIs that have it. But generally what you end up doing, I think, is putting params last and optional parameters in front of them.
That might also not be a real word. I might have made that up.
No. It's very close to the right word. There's a slightly related problem of what happens when you have arguments of different types. So it's not, because these are like, this is like all of the elements are strings here. There's also a similar problem of what happens when I have arguments of different types and I want to preserve those. And that was a different challenge we had to solve with another feature. So, but this takes us into 2017. 2017, we're like, okay, we're not doing params IEnumerable, but one day we will do param string. So the next time we kind of revisited this, because like I said, at this point, we are limited because we can't actually stack allocate these things because we don't have the runtime. The .NET runtime has no ability to give us that feature. Like we can't do it. It's not there. 2022 comes along and the runtime suddenly has some scenarios where they need to stack allocate. They need to be able to stack allocate essentially arrays of reference types. So objects, strings, what have you. And that was from a feature that I'm guarantee you no one in this room has ever used. It was a super low level, like we have to like solve a crazy interop problem between C# and C where we need bit for bit compliance with a crazy C data structure. Now in the language team, that was somewhat exciting. But what we were really excited about is they're going to give us stack allocations of reference types. We can solve this params problem finally. We're going to take that tool in the next version of C# and we are going to do param span of T. And then what happened at that time is we were like genuinely very excited to do this really kind of arcane .NET runtime feature because we're like, we're going to make params better. And at the time, we had a group of language design people go off and we said, okay, we're going to get this capability from .NET runtime. We know we're going to do param span and params read-only span. What other types should we let params start working for? And should we, for instance, let it work for IEnumerable now? And I had been one of the people who had, for the longest time, essentially telling people, like pushing back on params IEnumerable because I was worried about the perf implications. I even told that group, I'm like, hey, if we come back and say, like, let's make params IEnumerable work, because for people who care about performance, we can tell them what to do. Use param span. But if you don't care about performance and you just care about productivity, go ahead and use IEnumerable. I was like, I would support that. That sounds, just fine to me. That seems completely rational. Well, the group came back with what I thought was a really surprising thing. They said, we're not going to support it for anything but span. And the reason why is the time frame is now 2022. IEnumerable is not the type people are most using. People are either invested in like very concrete types like immutable arrays because they want to have like an immutable collection, or they were invested in much more strongly typed interfaces because in the meantime, we had introduced like iRead-only collection, which is very similar to IEnumerable, but it has a count in it, which is O of 1. So that's a very popular thing. Other people at this time had really started to embrace lists. So they were basically using these throughout their codes. And customers were essentially coming to us and saying like, I don't necessarily want to have params IEnumerable anymore. I'm using immutable arrays everywhere. Give me params immutable array. Give me params iRead-only collection or params list. And so the cheese had moved on us in a very significant way. And part of the problem that group ran into is they said, okay, well, they want all of these different types. Like, okay, maybe we don't do IEnumerable, maybe we do immutable array, but we're always faced with this problem of, let's say they put a mutable array of int here. Like this is their section. Like if they pass 1, 2, 3, how do we actually generate the code to create that immutable array? Like what is the best way to do it? Because if you look at all these different types, they have different ways of being initialized. So like spans, they have this really strange stack alloc syntax. If you look at kind of int arrays, like there's a number of different ways if you can actually initialize arrays. So you can do this really awkward like inline syntax. For things like a list of T, you might say, let me go use a collection initializer. If you try, you can type the same thing for immutable arrays. You can say, hey, let me go type off this like immutable array of 1, 2, 3. The IDE always crashes right when I do that. You can write this syntax. It doesn't actually work because of the nature of immutable arrays. You just end up generating code that does nothing, and we really need to give better diagnostics for that. And for iRead-only collection, like, what do we even put here? Like, how do we, if we let them put params in front of iRead-only collection, like, what type do we create to even pass to these? Because while array works in some cases, array doesn't work when we're targeting some like very old target .NET frameworks, where array doesn't necessarily implement that interface. And so we don't even know what to type here. And so the language design team kind of came back and said, one, the cheese has moved. And two, the things we would like to put params on, we don't know how to A, uniformly create instances of those, and B, how to do it with any kind of efficiency and performance. And so in 2022, we thought we had it. It came back and people said, nope, we're just going to do param span of T, and that is it. And honestly, that was what I guess say as a language design member, I was pretty deflated. I was like, wow, I thought we were going to get it that time, but I guess not. But then 2023 comes along and we start working on this feature called collection expressions. Now, if you haven't seen collection expressions, they are amazing. So collection expressions ended up wanting to solve, they were looking at this very problem in .NET. How many different ways are there in .NET to create what syntax we use to create a collection of items? Because you have stack alloc, you have this weird array initializer, you have collection initializers, you have all these other things. And you cannot uniformly apply the same syntax in all the different places. This, the syntax here for creating a list of T, it works. It produces a list with those elements. It does not do it in a very efficient fashion. There are much better ways to create that list of T, much faster ways. So collection initializers basically said, we're going to solve two problems. One, we're going to have one syntax for all of these collection scenarios. And two, that syntax will generate the fastest possible code that we can think of. And we will do horrible marshalling tricks to make it as fast as we possibly can. And that very much succeeded. So collection initializers now gives us this very beautiful syntax. And it works in every single one of these scenarios. We can just go type this in, every one of these, it works. Even in the case where we have an interface, we know how to turn that collection of elements into an object which implements that interface. And we know how to do it very efficiently. And so we're all happy and we're designing this collection expression feature and we're going along. And I've got to tell you, it might be obvious in this presentation where the dots are about to connect. The language design team, we looked at this for like 2 months before someone said the obvious thing, where they said, all the problems we just solved with the collection expressions are what stopped us from making params better. Because now we know how to create all of these types and we know how to create them all efficiently. What if we just said, any type that you can put on the left hand side of a collection expression, you can put beside a params array. And so, and this was really like kind of a moment in language design. We were all like, wow, we really should have thought of that about like 2 months ago. But it was a beautiful combination of these two problems that we have been working on for years. And it really kind of like pushed everything together in this one bucket. And suddenly there was a ton of energy in how can we make params awesome again? So, so this actually turned into a very different question. So the question of and the way that the call site ends up working is we say that, hey, whenever you type this particular like long form syntax, like 1, 2, 3, the way we actually call it is we just pretend you actually typed the collection expression. We generate the same code that creates the objects and it calls it. But getting back to params IEnumerable, this turned from a conversation of not, can we do params IEnumerable? The question became, can we have IEnumerable work with collection expressions? And turns out we know how to make that work, and we know how to make that work very efficiently. And because collection expressions work with IEnumerable, now it works over here. And these two call sites are basically exactly equivalent. And because we know how to make that collection expression very efficient, we feel very good about how we're introducing this in a framework and what performance this is going to have kind of at scale. All right. And so here, this is kind of a bit of a timeline of all the things I talked about of the various times we've looked at this feature in the past and why we had to reject it. Yeah. But kind of the takeaways from this is language design is hard. Even the simplest designs, some of the things I think are pretty much slam dunks, they can often pose very subtle challenges, particularly when you start looking at like compatibility and performance. And this design is nearly impossible to do in a vacuum. Customers' internal and external input into these processes are key. As you can hopefully see from kind of this process, that a lot of times the reason we were making these decisions and to ship or not ship was based sometimes on internal decisions, like do we have time, but also on external factors, like customers are telling us, go solve a different problem. You're not solving the right problem for me anymore. And while these can be very fun and very challenging, it's also quite fun. So now, one thing I want you to take away from this talk is that params is awesome. I know this talk focused on some of the deficiencies of params, and those deficiencies are like very important at the scale of the .NET libraries team. At a .NET application level, it's just really not that much of a problem. Keep using params. They are awesome. I did a counter and I looked in the .NET libraries code and I found like 2,200 and something uses of them. So even we love them. They're amazing. They're incredibly valuable. Keep using them. This talk is much more about like how things at scale can really influence like what we do in the language and what we do in the ecosystem. All right. So that's kind of it from the talk. And so kind of open for kind of Q&A.
All right. I did see a hand up earlier. I don't know if they had a question. If you do, you're more than welcome to come off mute and ask, or you can pop it in the chat, and it goes for anybody. If you've got a question, now's a good time to ask.
And also feel free, if you have other questions just about C# or like .NET in general, it doesn't have to be limited to the things I talked about here. I'm happy to answer all kinds of questions. Let's see if I get my face out of this amazing sunlight. There we go, a little better.
C#'s great. It just won't stop the sun from getting in your eyes.
I used to lock myself in a dark little closet for a long time when I had an office, but then they made me go to a team room.
All right. What is the easiest feature you've ever put into the compiler?
Easiest feature I've ever put in. Oh, dear God. I'm trying to think of what the simplest thing we've ever done is. Wow. I will say I think the easiest feature we ever did was private protected. So private protected, if you look at kind of accessibility in .NET, generally you have like public, private, internal, and protected. You do also have a slightly lesser known feature called protected internal. And protected internal is roughly the union of protected or internal. Now, if you actually go and look at IL, because C# in a lot of ways is just exposing capabilities that we have kind of at the .NET IL and ECMA 335 level. There's actually another combination of accessibility called, which was protected plus internal. So you had, in order to use a method, you had to be both derived from the type and in the same assembly from it. It took us, that was a feature that was actually very straightforward to implement in the compiler. It's literally like we have an accessibility enum, we have to add a new entry into it. It already maps directly into something that we have in IL. So it's literally just like put syntax, flip a different bit in IL. It took us 3 years to pick the syntax, but we eventually picked the syntax of private protected, and we shipped it on the basis of there is no syntax that everyone likes. This syntax works, and we really need to ship this feature. And so this was the syntax that people hated the least. And so we shipped private protected, and that was one of the easiest code reviews we've ever done. I would say probably the second easiest one we've ever done is, and one of what I think has been one of the more powerful and used features is if anyone has here ever used local functions or lambdas. One of the local functions, one of the kind of the downsides of local functions is they turned out to be incredibly popular. Within 3 months of us releasing the feature, I was dealing with crash dumps from customers, and I was working with them on like, let me see your code so I can figure out like what's going wrong with the compiler. And it's like, oh, I see what's going wrong here. You have a 10,000 line program that's in one function. You have like thousands of local functions, and the compiler was it was an interesting scaling problem. But customers started coming back to us because they said, we love local functions, but at a certain point, they kind of are too powerful because all of the implicit capture that they have. And it's so easy to read these locals. Every now and then I want to take this local function and I want to just basically say like, no implicit capture. I just want to have everything explicit so I can kind of think about this local function independently of everything else. And we did that by adding the static keyword in front of them. At the same time, we also start allowing you to put static in front of lambdas. And that meant that you now have these two pieces of code where you can say they're independent, they're little isolated blocks of code. I can think very concretely about them. And the implementation for that was actually very straightforward. It was probably one of the simplest features we've done. The naming is always the hardest part of marketing. You have no idea. So you don't know what bike shedding is until you've been to language design, where we can spend an hour talking about the difference between allow and allows. And after that hour, come to the conclusion that we need to meet again. I am not even joking. That is a very real thing we did.
That's the government method.
Oh, the craziest things I've seen people do. I mean, I've seen, I do want to say, like, I do often share stories of things that I've seen customers do. I think pretty much in every scenario, like, customers never set out to do a bad thing. Customers are, oftentimes when I get to a customer who is like in a bad place, it is because they have kind of tried something. They thought it was easy, and they, started digging the hole and digging the hole and digging the hole. And they suddenly got so deep that they had to end up, engaging someone from Microsoft to solve their problems. I mean, most of it is just innocent exploration that just gets taken to such an extreme level that we have to go and talk to them and be like, okay, no, like, this is how we kind of like rework things so that your code will be more efficient and work a little bit better with our tooling here. But, I mean, definitely seen some fun things over the years. It seemed like a good idea. That's a good one that we've had from customers. One thing I do often caution people is don't ask why, because sometimes you learn why people did things and then and it can be very hard to forget. I think C# is losing its authenticity with the attempt to hide public static void main. So I want to talk about that, because this is absolutely like that sentiment right there. Like, when we first started introducing this into the C# language design team, I can tell you, if you basically had everyone stand on one side of the room, like, do you want to have top level statements? Or do you want to, like, be able to just kind of like start typing code out in your file? You would pretty much say that, like, I think at the time it was kind of like David Fowler, and I believe maybe Damien was there, and Safia, and a couple of people from the web team came and like, hey, like, let's talk about having top level statements and how to make the ecosystem awesome. And you tell everyone, okay, if you believe in them, stand on one side of the room, stand on the other. You pretty much take the entire C# language design and stand up on the side of the room that's like, no, we shouldn't do this. This is a terrible idea. Like, we're just kind of like, this is syntactic sugar. We're not making anything better. And then you have basically everyone up, like Damien and Fowler and a bunch of other people on the other side of the room being like, no, we need to do this. The reason we did this, it's not so much that we are like losing authenticity. I think one thing people need to understand, it's like, languages don't exist in a vacuum. Like, we exist in some ways competition with other tool sets. Like, we try to think of, like, if you're like a high school kid, like, if you are coming into the world and you want to learn a language, like, what language are you going to learn? Like, you've never seen code before, and you see like kind of a C# 1.0 hello world thrown up on the board. What are you going to think? Like, what's that? We're going to be like, what's using? What system? Why do you have a semicolon? Like, if you actually sit down and look at this, like, people will go word by word of what you put on the board and be like, what does that mean? What does that mean? What does that mean? And you are 20 questions in before you get the hello world. And so the inability, like, putting that much ceremony in front of it makes it really hard for you. Like, when you look at things like Go, like, go write hello world and Go. It's like 2 lines of code. It's nothing. Like, Node is the same way. Python is even easier. Echo hello world. Like, it's trivial. And when you talk about like introducing people to a language and like getting them into the funnel, it can be an enormous barrier. And I speak from that because I was on the side of the room of, we need to do this. And the reason why I was on that side of the room is I used to teach high school AP computer science. And I got to tell you, we taught that in Java, but Java hello world at the time looked just like C# hello world. You put it up on the board, students are like, what's import? I'm like, ignore it. What's system? Just put this at the top of every one of your files. Like, what's this? Ignore the imports, kid. Like, go to the public. What's public? Ignore. What's static? I'll teach you about static in about like 3 weeks. What's void? It's like, what? And like, like I said, it's just, you really can't get people interested at that. And so this is in some ways competition. Also, I got to say, when we did this, I originally thought this feature, I really saw it as an education thing. It's like, how do we get customers onto the product? I thought I would keep typing public static void main for the rest of my life. No, that's so untrue. All of my programs now use top level statements, all of them. They are amazing. It is so much easier. Like this entire demo was in top level statements because it is so easy to use. Like there is little friction, the ceremony, like the unused parts of your screen, they are fantastic. It's one of the best things we've done, in my opinion. Let's see some other ones. COBOL is the first language to pick for sure. Perl is the real winner there, let me tell you. Am I a believer in WebAssembly? I'm not a great person to talk about that. So I spend most of my time on the compilers and like the .NET tooling ecosystem, kind of Visual Studio and VS Code. So I don't do a ton of work in WebAssembly. But I know a lot of people even who work for me who are very interested in WebAssembly and have actually done some work to get the C# compiler to run in WebAssembly for fun and profit. And they've had a lot of success with that. And it's pretty funny. It's pretty interesting to see. All right. COBOL is people are, I can't believe this. Zoom scroll is fun. Okay, so we had one about like how often is aggressive inline used through the runtime libraries. I would say I'm not sure off the top of my head, but you can look for it. It's all on GitHub. You can just go to github.net runtime, search for aggressive inline and see. I will tell you that where those are used, it is almost always a very like numbers driven conversation. Like we don't add like aggressive inlining for giggles. Like we do it because it's like we have performance traces, we have data, we look at the ASM, and we understand like where this is going to be a benefit to us and our customers to do it. And if you're ever doing that in your code, I very much encourage you to do the same thing. Oh my God.
All right, last call for questions.
If someone wants to know the deepest level, performance or torture, what would you say the best way to get? Okay, if someone wants to know C# at the deepest level, let's say for performance or because they like torture, what is the best way to get into the weeds? So first thing I would say is like every release of .NET, Stephen Tobe, who's a partner on the .NET Libraries team, does an amazing post like performance improvements in .NET whatever. It's appointment reading for me, even though I've often worked on many of the things that he is putting up there. That I would say is a fantastic way to get into it because it'll tell you, you can especially go through the history of this. You can go through and look at it and basically see what are the things that we have emphasized and why over a period of time. I would also say there are lots of great YouTube videos on how to learn performance tooling, like Perfew, like tons of great YouTube videos. If you get involved in the C# Discord, there's an entire, a strangely named channel in the C# Discord called Unsafe Code Blocks. And it is some of the people who do the craziest things with performance that I know. Like I said, I've been on .NET for 20 years now. I've been on the .NET team for 18. I go to that channel and I'm often like, wow, I've never even thought about that. That's amazing. So that is a great way to get involved. And you can also just follow along with the changes that the .NET team is doing on the runtime repo, because there are plenty of performance changes every day. And just reading and talking and asking questions is the best way to get involved. Extension methods, why not extension properties? That is, so extension properties, that's another one we've tried to ship about 3 times. If you actually look at the current version of C#, if you go and look at extension types proposal, we are looking to ship extension properties in .NET 9 C#13 finally. It is very much on our radar. We understand a number of scenarios that solves, and we feel like we finally have the mechanism to deliver that and other items like extension static methods, extension properties, extension operators. So that might be a feature that's big enough that we kind of dribble it out in phases. We'll give you part of the work in C#13, part of it in 14. But definitely like that is something we were very interested in.
Good.
Awesome. CLR via C# is an amazing book. That's actually the book I was given. The first time I encountered .NET was a research assistant in college. That was, I can't remember, the book had a slightly different title back then, but I got that book. I was basically handed a research job. I was like, you're going to use this new language called .NET when you're working for me. And I'm like, what's that? And they're like, here's a book, go learn .NET. And this was like .NET 1.0. And so that was my introduction to that book. The earlier version of that book is kind of my introduction to .NET 20 something years ago. AOT, how ridiculous is the process to get that implemented? I'm not the best person to talk about that with, but ridiculous. Taking a language which is basically designed to be just-in-time compiled for 20 years and making it so it can be ahead of time compiled is very challenging. Microsoft has kind of taken on this task a number of different times. When I was working in Midori and research, we had one particular approach we did for AOT. I think we had like some other pre-versions of like ahead of time compilation technology. And now we have the AOT, which I think is something that we've had a couple of different attempts, and this is the one we all think like this is the way forward and this is where we're going to be successful. So it's definitely one to read up on, but it is a very difficult problem in some of the edge cases. The good news is that team's been really awesome, and most code you can just kind of make trimmable, make AOT friendly with very little changes. Some of the more complex libraries have to do some more work, but it is, as someone who's worked on that problem before, to see how easy it is now, like it's like, wow, that's a lot easier than I ever thought it was going to be. Like they've made a lot of good progress on that. All right, so I think Terrence has his hand up.
No, that's Jeremy has his hand up.
Oh, sorry, it looks like that. Sorry, I'm
Oh,
not.
I see Jeremy clapping.
Okay.
We have one other question come in, and that is, what are the challenges with extension properties?
There are a couple. So the first is if you go like way back in time, like finding a good syntax for them is challenging. So like extension methods, very easy syntax. It's just name the method, go up there. What do you name the property? So do you basically tell customers, go and put all these APIs in your code, which are get underscore some name, set underscore some name. There are also some other deeper challenges with how generics work in properties that are very hard to overcome when you're trying to combine getters and setters across them. And really, that's kind of the root of the problem is we could never find a syntax that was in any way appealing. I mean, as soon as we give people extension properties, they're going to use them everywhere. And do we really want to give people a feature where we're suddenly saying go add underscores to your APIs all over .NET? Like that's not very clean. That doesn't look very aesthetic. And so that was one of the big challenges is like, how do we find that? How do we basically solve giving that in a very like pretty aesthetic way?
All right, I guess Alex is asking about type providers.
So can you clarify which type providers can be a little ambiguous? Can you clarify what you're asking there? There's a couple ways that can be interpreted. And by the way, come off mic, like unmute, talk to me, like happy to have back and forths.
All right, he's talking about F#.
Yeah, so it's in F# type providers, so why not do it in C#?
So you mean so type providers, like essentially they're kind of like source generation technology? Or are you talking about like active pattern type providers?
I don't remember. I used F# a long time ago. So
yeah.
But I think it's like.
Yeah. So type providers are essentially a way where you can kind of extend, you can have more or less plugins that kind of run in the compiler that generate various types that are then exposed to the program. They look and feel a lot like source generators when you kind of get down into their uses. Type providers, though, are a little bit different in how they are done because of where they plug into the compilation pipeline. And where they plug into the F# compilation pipeline, there were kind of a couple problems we had with that in C#. One is that it was not nearly as tooling friendly as we would have liked. And that, like I said earlier in kind of the talk, when we design features, we really try to design a complete item. And that includes like, can we have an awesome Visual Studio experience? Can we have an awesome debugging experience? It's not just putting things in the compiler. And with type providers, we felt that there was a lot of challenges with how the tooling would work around it. The other problem is the way type providers work is more or less you get kind of a system.type level view of the world. So when you're kind of like trying to build up the data models in F#, you're working with like system.reflection. We wanted, like, Roslyn is at the core, the C# compiler Roslyn is an API. We have a fully fledged syntax tree. We have semantic models, IOperation. We have incredible power for you to look at code and inspect it and get back data. And we wanted to give the entire power, and that API was already used in things like analyzers to provide like very fine grained diagnostics and analysis and details. And we wanted to give that exact same power to source generators. And as such, it kind of had to plug in a different way that type providers plug into F#. And so we do have type providers, but you can do the same thing you can do with type providers, but in C# and VB, you would do it with like a source generator.
Okay, thanks.
All right, I see another one is when in AOT will .NET code use garbage collector?
Essentially in the same places that you use today. Like I am guessing, so this is one, I'm kind of getting out of my depth on this one because I haven't really sat down and read up on the latest or AOT. I'm sure there's some cases where in AOT, because they have a more whole program view of the world, they can avoid some allocations with optimizations. But for the most part, I would say that you're getting the same type of garbage collections that you're going to get in your non-AOT applications.
All right. I think looks like we're about done with some of the questions for right now.
Okay.
I'll go ahead and stop the recording here just a second. Jared, thank you again for talking with our group tonight. Greatly appreciate it.
Yeah, thanks so much for having me. It's fun to give. I love giving talks like this. And like I said, I know you all hang out afterwards and chat. I'm going to hang out here for probably at least a half hour or so. And I'm happy to chat about anything, anything C# related. If you want to talk about how awesome infrastructure can be, like, I'm your guy. I love talking about infrastructure, or about the best places to eat in the South. I can also go toe to toe on those ones. Grew up in mostly Tennessee and Georgia. So happy to talk about fun barbecue places because we don't have a lot here. It's very sad.